So we're starting with 1, 2, where we will learn to find limits algebraically. So we've got a couple of slides to help walk us through these. Unfortunately, some of them are just laws, properties that we use for evaluating these limits. So I want you to pause here and write these all down. It's not so much a memorization as it is an understanding. And the good thing about most of, if not all of these laws, is they are quite intuitive. These are a lot of the properties that you typically used when combining functions, working with the compositions and combinations of different functions. So it's useful. You'll end up following those properties without even thinking about it. So what we're going to do, and I'm going to go to another slide for this, is we're now going to take those properties that I believe you wrote down, and we're going to evaluate them. So let's look at, and I put it here, let's look at the graph that you have and see if we can't evaluate these limits. And we'll go through sort of the procedure that we will use for these. So looking at the first one, part A, this is asking us to find the limit as x approaches -2 of this combination of functions, f of x plus 5 times g of x. So the one thing we're going to look at first is, this one, we're going to look at separately the limit as x approaches -2 for f of x. And let's see if that exists. So we go to -2, and we see right here at -2 that for the red graph, that our limit is approaching 1. So I can then replace that with 1. Now let's look at the limit as x approaches -2 for 5 times g of x. And you'll see that the property says that I can multiply whatever that limit is by 5, by the constant. And now I can just solely look at the limit as x approaches g, as x approaches -2 of g of x. So now we go to the blue graph, which is our g. And at -2, we look down and see that that limit looks to be -1. So this limit is -1 as we're approaching from both directions, the left and the right. Our y's are converging onto the -1 value. So that's 5 times -1, which is -5, and now I can combine those two. 1 plus -5, what, this gets so thick. And so part A leaves us with -4. I'm going to erase. So part A is -4. Nice and straightforward. I'm thinking I'm going to use this one. So let's look at part B. This is now taking the product as x approaches 1 of f and g. So again, we're separating the limit as x approaches 1 of f. Let's explore. So we're going to look at the red graph to see, can I evaluate that limit at 1? Sure can. That's 2. So that's the limit for the f of x. And I'm not going to keep writing it, but the limit as x approaches, I am going to write it as x approaches 1. Now let's look at the limit as x approaches 1, boop, 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 for g. So now I'm going to go to 1 for the blue graph, and that limit doesn't exist. But that does not mean that we immediately say, oh, that's a DNE. So let's see what else we have to do. This now means, since I know this one is certain, it's 2, I'm going to need to look at both scenarios to examine what's my situation as I'm approaching from both sides, from the left and the right, relative to G. So let's look at from the left. Oops, let's look at from the left. As I'm approaching 1 from the left, it looks like our G, blue graph, is approaching -2. Is that right? Yeah, that's right. And then as I'm approaching 1 from the right, it looks like our G graph is approaching -1. So I then take, and this is straightforward, right? I'm going to take both scenarios And obviously, you know that those two aren't equal, so we could stop. But we want to ensure that the solution that we ended up with here isn't the same numerical value, because if it is, then that combination of functions has a limit. And here, since they don't, B is DNE. And then for C, we're going to look at, struggling picking a color, we're going to look at the ratio as x approaches 2 of f over g. So now let's just look at separately the limit as x approaches 2 of f. So I'm going to 2 and identifying what that limit would be. And as I'm approaching 2 for my red graph, it looks like our limit for f is 1. All right, over, and now let's do the same for g. As our x approaches 2 for g, that looks like it's approaching 0. And you might remember it's approaching 0, that means at some point this is approaching one of the infinities, right? So again, we want to plug this in and identify, is this possibly approaching infinity from both sides or negative infinity from both sides? Let's take a look. So now let's look at our limit as x approaches 2 for g, except we're going to do 2 from the, let's do, 2 from the right. Let's start with the right and then we'll look at 2 from the left. So we know that they both approach 0, but let's look. As I'm approaching 2 from the right, I hope it's clear to you that my values are approaching 0, but from a positive direction, right? So this is approaching 0, but it's a small, so it's 0, right? But it's a small positive number. And 1 over a small positive number that's getting closer and closer to 0 approaches infinity, positive infinity to be more specific. Now, as I'm approaching 2 from the left, that's when we're seeing that it's approaching 0, correct? But from what direction? So now it's approaching 0, but it's getting tiny, tiny, and it's a small negative number. So what's my issue when I have 1 over a small negative number? Well, that approaches negative infinity. So our conclusion, because they're approaching different values from both sides, we get a DNE. Knowing what we know now, let's try and do this one problem. This is an AP multiple choice question. So pause me and give it a shot, see if you get the answer. All right, so if we are going to look at this problem, we are trying to, first let's highlight. It's asking us which of the following is false. All right, so part A says, oh, why is this so blurry? That the graph, the limit as x approaches 1 of f is 0. So here's my f graph. That's f, and then this one's g. As I'm approaching 1, I'm looking from both directions, as I'm approaching 1 from the left and from the right, it looks like our limit of f of x is in fact approaching 0. That is true. So let's nix A, let's go to B. The limit as x approaches 2 of g, so now I'm looking at my g graph, does not exist. That is correct, because if we're looking as we're approaching 2 from the left, our y values are approaching 1. As I'm approaching 2 from the right, our y values are approaching -1. So since this is, I'll not put check because that's confusing. This is true, so we nix this. All right, now we've got these two functions that are the two C's and D's that we need to entertain. The first one says the limit as x approaches 1 of f of x times g of x plus 1 does not exist. Let's explore. So the limit as x approaches 1 of f, we've already done that. We know that that's 0. So for the limit as x approaches 1 of f, we know that equals 0. Okay, so now let's look at the g then. So the limit as x approaches 1 of g of x plus 1, so let's see, that's going to approach, so g of 1 plus 1, so let's think of it this way. 1 is going to be something like this as x approaches 1, and then I'm also going to think about values like, this is what I'm doing. This is my thought bubble. This is what's going on in my head as I'm approaching 1 from both directions, right? From the left and from the right. So now let's look. So let's see. The limit as x approaches 1 from the left. So that would be this one right here, right? If I'm thinking 0.99. So let's see. So that would be g of 1.99, like ish, right? And that's approaching, so g of 1.99, that's approaching 1 from the left, and that is clearly approaching 1 because I'm looking here, 1.99, 1.9999, those are all going to approach 1. So now look at what happens as I'm approaching 1 from the right, and that's where I'm looking at the second value, like the 1.001. So that looks like we're thinking of it as g of 2.001, and that is coming from this direction, and that is approaching -1. So we know that that's a DNE with respect to G, but that's not what we're looking for. In part C, it's the product of those two. And ho, 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 look at what the f of x is. It's 0. So when we take the product of f of x and g of x plus 1, that's going to be 0. If I'm thinking of 1 from the left, that would be 0 times 1, which is 0. But then the other scenario, 1 from the right, is 0 times -1, which is what? Which is also 0. So part C, that limit actually does exist. So this is false. That's our answer. Let's just affirm this by making sure that D is true. So D is the limit as my x approaches 1 of f of x plus 1 times g of x. They're saying that does in fact exist. So, exploring and buying time so I can erase. So let's see. So that first one looks like it's the limit as x approaches 1 of f of x plus 1. So then that would be close to 2. So let's see. So in this case, from both directions, that's still going to approach -1. So I know that that's -1. Now let's look at the other. The limit as x approaches 1 of g of x. As x approaches 1 of g of x, and that is actually 1. So if I take -1 times 1, and there's no ambiguity here, right? It's not that's not a one-sided limit where I need to look at the left and the right because it's both -1, both directions, both 1 from both directions. So that gives me -1. And so that in fact does exist, and that's true. And that leaves us with C.